What happens when you take a gasoline engine, crank the compression to diesel levels, and hope for the best? You get 380,000 warranty claims, a class action lawsuit worth $128 million, and an engineering disaster so spectacular it killed diesel passenger cars in America for an entire generation. This is the story of the Oldsmobile 350 diesel V8, the engine that started as GM's answer to the oil crisis and ended as one of the most catastrophic engineering failures in automotive history. Picture this. It's 1973, and Americans are sitting in gas lines that stretch for blocks. The Arab oil embargo just quadrupled fuel prices overnight. Suddenly, your Cadillac Fleetwood that gets 8 miles per gallon isn't just expensive, it's becoming impossible to fuel. Panic is setting in at GM headquarters. Their entire lineup consists of massive V8-powered land yachts, and customers are fleeing to Japanese imports that sip fuel like hummingbirds. Something had to be done, and fast. General Motors decided they would revolutionize American motoring by bringing European-style diesel efficiency to full-size American cars. The Oldsmobile 350 diesel V8 would deliver 20 to 30 miles per gallon in cars the size of living rooms, all while maintaining the smoothness and refinement buyers expected. At least, that was the plan. What actually happened would become a cautionary tale taught in engineering schools about what happens when accountants overrule engineers. To understand the magnitude of this disaster, we need to travel back to the late 1970s. Mercedes-Benz was selling diesel sedans that ran forever, 300,000, 400,000, even 500,000 miles without major repairs. Their cast-iron blocks were specifically engineered for diesel's brutal compression ratios. Volkswagen's Diesel Rabbit was getting 50 miles per gallon when most American cars struggled to hit 15. The market was primed for an American diesel revolution. GM saw the opportunity and pounced. But here's where it gets interesting. The problem wasn't the concept, it was the execution. See, developing a proper diesel engine from scratch takes years and cost hundreds of millions in 1970s dollars. You need specialized metallurgy for the block, different bore spacing, reinforced main bearing caps, stronger connecting rods, a completely different head design to handle compression ratios that would destroy a gasoline engine in seconds. Mercedes spent 5 years developing their OM617 diesel. GM gave Oldsmobile 18 months and told them to use existing tooling, so Oldsmobile's engineers did what they were told. They took their existing 350 cubic inch gasoline V8, the same basic block that powered millions of Cutlasses and Delta 88s, and tried to convert it to diesel operation. The gasoline engine ran a compression ratio of 8.5 to 1. The diesel version, 22.5 to 1. That means the air-fuel mixture was being compressed to less than 1/22nd of its original volume before ignition. The pressure inside each cylinder at the moment of combustion reached 1/800 psi. The gasoline block was designed for maybe 600. The modification seemed logical on paper. They used a reinforced crankshaft made from nodular iron instead of cast iron. The main bearing caps got extra bolts, 4 per cap instead of 2. The head bolts were upgraded from 7 to 16-inch to 1 2-inch diameter. They installed sodium-cooled exhaust valves to handle the higher temperatures. The camshaft was reground for diesel timing. New pistons brought the compression up to diesel levels. A Rusamaster rotary injection pump replaced the carburetor with pencil-type injectors delivering fuel at 1,800 psi directly into the combustion chambers. But wait, there's more. The cylinder heads themselves were essentially the same castings as the gas engine, just with smaller combustion chambers to achieve that crushing compression ratio. The block cylinder walls weren't thickened. The deck surface wasn't reinforced. The head gasket was just a slightly beefier version of the gas engine's design. GM was essentially asking a marathon runner's skeleton to support a weightlifter's muscles. Testing seemed promising at first. Prototypes delivered 25 miles per gallon in city driving, 30 on the highway in full-size cars that previously struggled to break 12. The engines started reliably, even in cold weather, thanks to a sophisticated glow plug system. GM's marketing department was ecstatic. They rushed the engine to production for the 1978 model year, available in everything from the Oldsmobile Delta 88 to the Cadillac Seville. The diesel option cost an extra $850, about $3,800 in today's money. Buyers lined up. Initial sales exploded. In 1978 alone, GM sold 56,000 diesel-equipped cars. By 1981, that number hit 310,000 units per year. The Oldsmobile Cutlass diesel became the best-selling diesel car in America. Customers loved the fuel economy. Some reported over 30 mpg highway in 4,000-pound cars. The torque was impressive too. 220 pound-feet at just 1,600 RPM made these cars surprisingly quick off the line. For about 6 months, everything seemed perfect. Then the failures began. And I mean catastrophic engine-destroying failures that left owners stranded and furious. The first sign of trouble was usually a slight coolant leak around the head gasket. Within days, that leak would become a geyser. The head bolts, despite being larger than stock, weren't nearly strong enough for diesel pressures. They stretched like taffy under the constant pounding of 22.1 compression. Once stretched, they couldn't maintain proper clamping force on the head gasket. Let me explain what happens when a diesel head gasket fails. It's not like a gasoline engine where you might get some coolant in the oil or a rough idle. When 1,800 psi of combustion pressure finds a weak spot in a head gasket, it cuts through like a plasma torch. Coolant gets injected directly into the cylinder at the moment of combustion. The incompressible liquid causes hydrolock. The piston slams into a wall of water instead of compressible gas. Connecting rods bend. Sometimes they punch through the block. The engine dies violently, often with a bang that sounds like a sledgehammer hitting concrete. But head gasket failure was just the opening act. The real disaster was happening in the fuel system. See, European diesels in the 1970s ran on relatively clean, low-sulfur diesel fuel with good water separation at the pump. American diesel fuel was designed for semi-trucks, not passenger cars. It was dirty, full of water, and contaminated with everything from gasoline to kerosene, depending on the station. The Rusamaster injection pump GM chose was designed for agricultural equipment running on consistent, clean fuel. It had almost no water separation capability. Water in diesel fuel is death to injection systems. When water passes through an injection pump designed to create 1,800 psi, it doesn't compress like diesel fuel. Instead, it causes cavitation, tiny explosions that eat away at the pump's precisely machined surfaces. The tolerances in a diesel injection pump are measured in 10,000ths of an inch. A few specks of rust or water damage, and the whole system fails. Replacement pumps cost $800 in 1980, about $3,000 today. The injectors suffered even worse. Those pencil-type injectors had tiny orifices that sprayed fuel in a precise pattern for proper combustion. American diesel fuel, especially in winter, often contained paraffin wax that would crystallize and clog the injectors. One clogged injector meant that cylinder wasn't firing properly. The unburned fuel would wash the oil off the cylinder walls, causing accelerated wear. The engine would shake violently, belch black smoke, and eventually destroy itself from the inside out. GM's solution to the fuel problem? They told owners to add a bottle of injector cleaner every tank and change fuel filters every 5,000 miles. Problem was, they didn't tell owners this until after the failures started. The owner's manuals barely mentioned diesel-specific maintenance. Dealers didn't stock the special fuel filters. Most mechanics had never worked on a diesel car and treated them like gasoline engines. They'd overlook critical warning signs until catastrophic failure was inevitable. But here's the kicker. Even perfectly maintained engines were failing. The block itself couldn't handle the stress. The main bearing webbing would crack after 30,000 miles of diesel pounding. The cylinder walls, designed for gasoline's gentler pressures, would develop stress fractures. Oil consumption would skyrocket as the rings lost their seal. Some engines burned a quart of oil every 300 miles before finally giving up. The horror stories from owners were legendary. A traveling salesman in Ohio watched his engine explode on I-71, leaving a trail of oil and coolant for a quarter mile. A grandmother in Florida had her engine seize solid in a Publix parking lot with just 18,000 miles on the odometer. A Cadillac Seville diesel owner in California went through 3 complete engine replacements in 2 years. Each story spread through communities like wildfire, destroying GM's diesel reputation bit by bit. By 1981, the situation was catastrophic. GM's warranty claims for diesel engine repairs exceeded $100 million per year. Dealers were replacing entire engines at 8,000, 15,000, 25,000 miles. Some dealers had parking lots full of dead diesel cars waiting for replacement engines. The backlog for parts stretched months. Customers were given loaner cars for so long they forgot they owned diesels. The technical patches came fast and desperate. In 1981, GM reinforced the block with thicker main webs. They upgraded to a roller cam for better durability. The head bolts got bigger again, now 9/16-inch. They added a water separator to the fuel system. The injection pump was recalibrated for American fuel. They even developed a special diesel engine oil, claiming regular oil couldn't handle the soot and combustion byproducts. For 1982, they introduced the DX engine, the fixed version. It had a stronger bottom end with 4-bolt mains throughout. The heads were redesigned with better cooling passages. They added an engine-driven vacuum pump since diesels don't create manifold vacuum. The fuel system got a larger filter with better water separation. On paper, it addressed every known failure point. But the damage was done. Word of mouth had destroyed consumer confidence. Magazine reviews were brutal. Consumer Reports called it the worst engine GM ever built. Popular Mechanics ran a feature titled, "How to Convert Your Olds Diesel Back to Gasoline." The resale value of diesel-equipped GM cars plummeted to basically nothing. You couldn't give them away. The lawsuit started in 1979 and snowballed into an avalanche. Customers sued for breach of warranty, false advertising, and fraud. They claimed GM knew the engines were defective, but sold them anyway. Internal documents revealed GM engineers had warned management about the head bolt problem before production started. The recommendation for stronger bolts was rejected to save $28 per engine. In 1984, GM settled a class action lawsuit covering all 1978-1980 diesel owners. The settlement cost $128 million and extended warranties to 100,000 miles. GM also agreed to reimburse owners for certain repairs and offer trade-in credits toward new GM vehicles. It was one of the largest automotive settlements in history at the time. Meanwhile, Mercedes-Benz was building their OM6 Juan 5-cylinder diesel that routinely lasted 500,000 miles with basic maintenance. The engine used a proper diesel block with twice the iron content of a gas engine. 7 main bearings supported the crankshaft. The head was secured with 18 bolts torqued in 3 stages. The Bosch injection pump was engineered specifically for automotive use with excellent water separation. These engines were so reliable that many are still running today, 40 years later, in W123 sedans all over the world. Volkswagen's 1.6-liter diesel was similarly bulletproof. Sure, it only made 48 horsepower, but it would make that 48 horsepower forever. The indirect injection design was noisy and slow, but incredibly tolerant of poor fuel quality. Taxi drivers in Europe were getting 400,000 kilometers without rebuilds. The contrast with GM's disaster couldn't have been starker. The Oldsmobile diesel contaminated the entire concept of diesel cars in America. Before 1978, Americans associated diesels with longevity and efficiency. After the Oldsmobile disaster, they associated them with breakdowns, black smoke, and worthless resale values. When Volkswagen tried to sell their excellent TDI engines in the 1990s, they faced an uphill battle against memories of the Oldsmobile nightmare. GM tried to salvage something from the wreckage. They developed a 4.3-liter V6 diesel for 1982, built from scratch as a diesel rather than converted from gas. It was actually a decent engine, reliable, efficient, and smooth. But nobody wanted it. The damage to GM's diesel reputation was total and permanent. They also created a 5.7-liter V8 diesel for light trucks that was properly engineered and relatively reliable. It found some success in suburban and pickup applications where buyers were more forgiving. But for passenger cars, the diesel dream was dead. The irony is that the concept was sound. A properly engineered diesel V8 would have revolutionized American cars in the 1980s. Imagine Cadillacs getting 30 mpg highway with Mercedes-like reliability. The technology existed, GM just chose not to use it. They tried to dieselize a gasoline engine on the cheap and paid the ultimate price. Let that sink in for a moment. GM could have licensed Mercedes diesel technology. They could have hired European diesel engineers. They could have spent the money to develop a proper diesel from scratch. Instead, they took shortcuts that destroyed customer trust for a generation and cost them billions in warranties, lawsuits, and lost sales. The technical postmortem is damning. The gasoline block's deck surface was only 0.425 inches thick. Diesel blocks need at least 0.750 inches to handle the pressure without flexing. The head bolts were torqued to 130 pound-feet, but diesel pressures required at least 180. The compression ratio of 22.51 was actually too high even for diesel. Most automotive diesels run 19.1 for better reliability. Every engineering decision prioritized cost savings over durability. The few survivors today are curiosities. Some enthusiasts have retrofitted them with proper head studs, upgraded gaskets, and modern injection pumps. With these modifications, they can actually be reliable engines. But it took aftermarket ingenuity to fix what GM should have built correctly from the start. A properly modified Olds diesel can deliver 25 mpg in a classic Cutlass, exactly what GM promised but never delivered. The cultural impact lasted decades. The phrase Olds diesel became synonymous with automotive disaster. It joined the Edsel, the Vega, and the Pinto in the Hall of Shame. Mechanics would refuse to work on them. Insurance companies charged higher premiums. Some states even required special emissions testing because so many burned oil like fumigation machines. Think about that for a second. GM took a market ready for diesel innovation and poisoned it so thoroughly that Americans wouldn't consider diesel cars for 30 years. Even today, despite excellent modern diesels from BMW, Mercedes, and others, Americans remain skeptical. The ghost of the Oldsmobile diesel haunts every diesel car sale in America. The human cost went beyond money. Families were stranded on vacations when engines grenaded. People lost jobs because their cars were constantly in the shop. The stress of owning an Olds diesel, wondering when, not if, it would fail, took a genuine psychological toll. GM turned their customers into unwitting beta testers for a fatally flawed design. The engineering lessons are crystal clear. You cannot convert a gasoline engine to diesel by just changing compression and fuel delivery. The metallurgy, geometry, and cooling systems are fundamentally different. Diesel requires purpose-built components designed for 3 times the cylinder pressure and completely different combustion characteristics. There are no shortcuts in diesel engineering. Modern diesel technology is light years beyond the 1970s. Common rail injection operates at 30,000 psi with multiple injection events per combustion cycle. Piezoelectric injectors respond in microseconds. Variable geometry turbos optimize power and efficiency across the RPM range. Modern diesels are quiet, clean, and incredibly powerful. But in America, they still fight the stigma that GM created with one catastrophically bad engine. The business lessons are equally clear. When you rush engineering to meet market demands, you don't save money. You lose billions. When you ignore engineer warnings to save a few dollars per unit, you pay hundreds of millions in warranties. When you beta test products on paying customers, you destroy brand loyalty that takes generations to rebuild. Here's something that still amazes engineers today. GM knew how to build good diesels. Their electromotive division built locomotive diesels that ran millions of miles. Detroit Diesel made engines for buses and trucks that were legendary for durability. The expertise existed within the company. They just chose not to use it for passenger cars because they wanted it fast and cheap. The final production numbers tell the story. From 1978 to 1985, GM built approximately 1.1 million Oldsmobile diesel engines. Industry analysts estimate that over 380,000 warranty claims were filed. That's more than 1 in 3 engines suffering catastrophic failure under warranty. The actual failure rate was likely higher since many owners just gave up and paid for gasoline conversions themselves. The conversion industry actually became huge business. Shops specialized in yanking out the diesel and dropping in a traditional 350 or 403 gasoline V8. The conversion cost about $3,000 but restored reliability and resale value. Some shops were doing 5 conversions per week at the height of the disaster. They couldn't convert them back to gas fast enough. In the end, the Oldsmobile diesel V8 stands as perhaps the most consequential engineering failure in automotive history. Not because it was the worst engine ever built, there have been worse, but because it was deployed at such massive scale, at such a critical moment, with such devastating consequences for an entire technology's reputation. It proved that there are no shortcuts in engineering. You cannot will a gasoline engine to become a diesel through wishful thinking and minimal modifications. You cannot ignore physics to meet quarterly earnings targets. You cannot treat customers as test subjects and expect to maintain their trust. Every single Oldsmobile diesel that grenaded its head gasket or melted its injection pump was a rolling advertisement for never trusting GM or diesels again. The legacy lives on in unexpected ways. The phrase, "It's not an Olds diesel," has become engineer shorthand for properly designed for its intended purpose. The disaster is taught in business schools as a case study in how rushing products to market can destroy decades of brand equity. The technical failures are analyzed in engineering programs as examples of what happens when you exceed design limitations. So, the next time you see a modern diesel car purring quietly at a stoplight, delivering tremendous torque and exceptional fuel economy, remember that it's fighting a battle that started in 1978. Every Mercedes BlueTech, every BMW diesel, every Chevy Cruze diesel has to overcome the ghost of the Oldsmobile 350 diesel V8. They have to prove they're not another disaster waiting to happen. What could have been GM's greatest triumph, bringing efficient diesel power to American luxury cars, instead became a cautionary tale about corporate hubris, engineering shortcuts, and the devastating cost of betraying customer trust. The Oldsmobile diesel V8 didn't just fail as an engine, it failed an entire generation of American car buyers who learned the hard way that sometimes saving money costs everything. The bitter irony? If GM had spent the money to engineer it properly from the start, the Oldsmobile diesel V8 could have changed American automotive history. Instead, it became a punchline, a lawsuit, and a permanent scar on diesel's reputation in America. That's the real tragedy, not that it failed, but that it never had to fail at all. What's the worst automotive disaster you've witnessed? Drop a comment below and share your story. And if you enjoyed this deep dive into engineering failure, hit that subscribe button for more tales of automotive ambition gone wrong. Until next time, remember, there are no shortcuts in engineering, only expensive lessons learned the hard way.